We're going to start with factoring. So this is going to extend for a while because factoring is pretty involved. We're going to use a lot of factoring in the next couple sections. So when we talk about quadratics, and then when we come back and talk about polynomials some more. So we're going to start with just the very basics of factoring, which is finding a common factor and factoring that out, and then doing what we call factoring by grouping. So to factor a polynomial is to express it as a product. A factor of a polynomial p is a polynomial that can be used to express p as a product. So we talk about factors in general. So if I gave you 12, 12 is made out of 3 and 4. So those are going to be factors. That's what I mean by factors. So when we talk about a polynomial having factors, well, technically that is a polynomial, but if I gave you something like 2x squared plus 3x, well, technically I can rewrite that as x through x plus 3. And in this case, this and this whole part here are both going to be factors. That's when we talk about factors of a polynomial. If I could break it down into two things that multiply together, give me that same polynomial, then those two things are factors. So the factorization of a polynomial is an expression that names p as a product of factors. And what we're trying to do here when we factor a polynomial is we want to do a complete factorization. We want to break it down as far as we can. Okay. So we can start this with, we want to figure out something that both of these terms are divisible by. And one of those things is we can divide both terms by 9. This is how we do a factoring. So both of those are divisible by 9. So technically what I'm going to do is I want to divide by 9, but I want to keep this expression as equivalent. So I'm going to multiply by 9 on the outside. Okay. So because this is subtraction, if you did like fractions or anything like that, as long as they have the same denominator, you can add them together. That means if I could break them up and have the same denominator. So this is just 9. And if I had 9m squared over 9, that's just going to leave me with m squared. And 27 divided by 9 is just 3. So this is the factorization of this. So if I had 9m squared minus 27, both terms are divisible by 9. So essentially what I do is I pull out a 9, I divide it from both numbers and pull it out front. And what's important is that if I distribute this 9 right back through, I would get 9m squared minus 27. So it is this, it's equivalent expression. It's just a factored equivalent expression. But like I said, these are my two factors. Okay. So this is one of my factor. And this is my other factor. So these are two factors that I have of 9m squared minus 27. This is another example that we need to go back over. Okay. So if I gave you, I think there's a slide that I'm missing. If I gave you these three terms and I asked you to factor, we're trying to find something that divides all of these. And we know all these numbers are divisible by 5. We also see that we have an x. Everything's divisible by an x. So we want to figure out what the maximum amount of x's I can divide everything by. Well, here I could divide by 3, 6, and 2. So all of them are divisible by at least 2. And then we look at the y's. We know we can divide everything by a y. And the question is, what power of y? Well, we have a 4, a 3, and a 5. We're going to pick that 3. So when we're trying to find what we can divide everything by, and we have variables, we pick the variable of the smallest power that all of them share. But now if I did that, 25x squared y cubed. If I factor it out of everything, that means this is 25x squared y to the 5th, and I'm factoring out a 5x squared y cubed. And we have 35x 6th y cubed. We're dividing that by 5x squared y cubed. And then I have a 15x squared y to the 4th, and I'm dividing that by a 5x squared y cubed. So once I do that, that means 25 divided by 5 is going to leave me with 5. I have an x squared and x squared, those are gone. I have a y cubed and y to the 5th, so I'm just going to be left with 2 of my y's. 35 divided by 5, that's going to leave me with 7. I have x squared, x to the 6th, so that's going to leave me with only 4 x's. And the y's cancel out. And then for my last case, I have 15 divided by 5. That will leave me with 3. I have x cubed and divided by x squared, and leave me with just 1x. And I have y to the 4th divided by y cubed, which is going to leave me with just 1y. So I like dividing everything out, and we're just keeping what's left over. So ideally, what we're doing is we're finding the largest thing that we can divide out of all of our numbers. So another way of looking at it is you're finding the largest number I can divide out of 25, 35, and 15, which is 5. The largest number I can divide out of x squared, x6, x to the 3rd, which is x squared. And the largest I can take out of the divide from the y is the y 5th, y 3rd, y 4th, which would have been that y 3rd. So when we say something is factored completely, that means we can't factor any further. So if we hit a point that I cannot factor out anything other than 1, then we have factored completely. So the last 2 cases, I believe, yeah, we factored those completely. So the factors in the resulting factorization are said to be prime polynomials. So because they're prime polynomials, that means they cannot be factored further. So ideally, if we have something that is completely factored, then it's just going to consist of a product of prime polynomials. So when the leading coefficient is a negative number, we generally factor out a common factor with a negative coefficient as well. So just another thing, if my leading coefficient is negative, what we're going to factor out is going to be negative. So for example, I want to write an equivalent expression for negative 4x squared minus 16x by factoring out a common factor with a negative coefficient. So I see here that both of these numbers are divisible by 4. So I want to make sure I factor out 4. So this leading term here, my negative 4x squared is negative. So I'm going to factor out negative 4. Then we see both of them have an x, so I can at least factor out x. So if I do that, negative 4x squared, and if I factor out or divide by negative 4x, will just leave me with positive x. Negative 16x, if I divided it by negative 4x, would just leave me with plus 4. So remember, when I'm pulling this number out, it's essentially dividing it from here and here. And I can't factor this polynomial here further, and there's not much more I can do to factor this one. So we're completely factored. Okay, so on your worksheet, let me rescale that. Okay, as long as I was trying to remember to give you another set on here. Just 3 problems. So all you want to do is try to factor out the greatest common factor. And if you make a mistake, don't worry about it, because there's some common mistakes we make here. I'm going to kind of go back and talk about some of those. Okay. So for A here, we see that not all my terms have an x. When I factor, we're not going to contain an x at all. So most of the cases we had everything there was a shared variable, but we don't always have that. Oops. Term, not every term has x. So we are not going to factor our one out. So we do not. This is one of the first things I want to point in case you try to do that. We have to have everything contain the same variable to try to factor it out. So in this case, what we see is everything is at least divisible by 2. So I'm going to try factoring out a 2. So if I divided all of these by 2, what I'm going to be left with is 3x squared minus 15x minus 1. And there is a possibility this could be factored further. I don't think so. But as far as we know, this is the best that we can do. This is completely factored for us. What we're going to see next week is that I can actually kind of maybe be able to factor that a little further. So for B, in this case, everything's divisible by 3 and at least 1x. So if I divide that 3x out of everything, I'm going to be left with an x squared, a negative 9x, and then a negative 4. So everybody lost at least an x, and then we divided everything by 3. I'm pretty sure I think that one is completely factored. I'm taking here a quick second. Yeah. So C, here, remember, because we got that negative out front, we definitely want to factor out a negative. In this case, we have a 7, we have a 3, and a 5. The only thing they have in common is 1. But when we have that negative out front, we want to factor out a negative. So in this case, it's just going to be negative 1. And then we see everything shares an x, so I can factor out an x as well. So if I factor out a negative x, I'm just left with positive 7x. I think that was supposed to be a cube there, by the way. Make a little note there, because otherwise this is just silly. This is a cube. This should have been a cube. So that should have been negative or positive 7x squared, but what's important is it turns to a positive. We're getting rid of a negative x here, so that's going to be positive 3x. And then a negative x here, which is going to turn that to a negative 5. So we don't write negative 1x necessarily. We would just say negative x times 7x squared plus 3x minus 5. Usually the biggest mistake, like I said, is not realizing that everything, it doesn't have an x, so you can't pull an x out of everything. And sometimes you have a situation like C where they don't have really a common divisor among the actual numbers. It's just 1. In this case, remember, if it starts with a negative, I have to factor the negative out.